Hey class, in this video, I would like to go ahead and focus on how to build a truth table for a compound statement. So suppose the question asks you to build a truth table. So the instruction will say, build a truth table for the statement, and here is the statement, not R implies not Q and P. Okay, so when we are looking at this statement here that we need to build a truth table for, the first thing then we would notice is that it has three simple statements. And the three simple statements are P, Q, and R. Okay, before we even proceed to do anything, we should think, okay, well, if I have three simple statements and each one of them has two choices of truth value, because we know that a statement can either be true or it can be false, right? So a statement is a complete sentence that can be true or false, but not both at the same time. So when you think about the possibilities, how many possible ways can you rearrange these truth values, knowing that each one of them have two choices? And if you haven't seen it before, here is a thing that is called a multiplication principle. That said, if P has two choices and Q has two choices, and then R had two choices of truth values, then there are a total of 2 times 2 times 2, which is 8 possibilities. All right, so the question is, how do you list those 8 possibilities? How do you list those 8 possibilities? Okay, so what I would do is I would go ahead and start with true, 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 and then I would alternate the truth value, right? So the next thing could be true, true, false, and this could be true, false, true, and then this could be true, false, false. Now, if we notice the first four that are here, okay, it will look like when you have two choices, right? That when you have two choices, you have true, 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 false, false, true, false, false, right? But when you have three choices, I would list this systematically. The first four would be when P is true, and then the second four would be when P is false. Okay, so then I just go ahead and repeat the pattern of your true, 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 false, false, true, and then false, false, right? You've done this enough, you'll kind of know how to list these. So make sure that it works in your head, okay? Now, then what do you do next, right? The question that people always have issues with is what happened after you list these choices? Okay, so after you list these choices, you would say, you know what, I'm going to do that one more time. Let's do that one more time just so you see how that works. I know you can pause the screen, but I think I'm going to go ahead and do that as I am thinking so you can see the system of how to list this, okay? And also, I want to go ahead and give a space in between so my paper is a little bit easier to read. All right, so here we go. First, we know there are 8 choices, right? So this one could be true or it could be false. So my first 4 out of the 8 would be when P is true. And then the next 4 would be when P is false. And that's how I think about my listing. And then I would list my normal 4 choices for Q and R. If I have just Q and R, I would have 4 choices, right? So the choices are true, 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 false, false, true, and then false, false. And then what am I going to do with the other 4? Repeat. True, 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 false, false, true, and then false, false. So there are my 8 possibilities. Okay? Now, the thing is, after you list all of those possibilities, so the truth table is a table that exhibit all of the choices of truth values, right? So these are all of the possibility of truth values for when you have 3 simple statements. Now, what do we do next? Well, we have to pay attention to the order of connectives. Okay, so we have to pay attention to the order of connectives. So what is the order of connectives? The order is, first, you would have anything inside parentheses, and then second, you would have negation, and then third order would be and, or would be next, and then the fourth choice would be if and only if, and then lastly, you would have, fourth choice would be if then, and then lastly, you would have if and only if. So those are your order of connectives, right? So the statement that you have there is, okay, so here is your statement, not R implies not Q and P, right? So the first order would be inside that parentheses. So when you go inside of this parentheses here, which would you operate on first? You would say negation first. So the first thing you would list would be not Q. And then the second thing you would list would be the and connective. So that would be not Q, and P would be your next order, right? Now, when you're done with this part, we would go and look at this part right here. So the third order that you would list is not R, and then after that you would have this connective right there. So the fourth order would be not R, then not Q, and not and P, right? So that is how you can kind of prioritize your order of connectives when you are building a truth table. Okay, so what does that mean into here? It kind of dictates what you will list next in your truth table. Okay, so here I would list not Q would be my next column because that's the order of connectives. I would go here first, right? And then second, I would go here. So that would be not Q and P. Okay. And then next, I would go here. That would be my third order, not R. And then lastly, I would have the fourth order there would be if and if then. Okay, so that would be not R, which is my previous column, then not Q and P. Okay, so that would be my last column, which is my entire statement. So that's how the order of connectives will work. So here, not Q. So let's go and figure it out, not Q. Not Q would have the opposite truth value of Q. So this column would be the opposite of Q. So Q in the first line is true. So not Q would be false. Q is true, not Q would be false. Q is false, not Q would be true. True, false, false, true, true. Okay, so that would be my blue column there. And then for this column here, so I'm going to go ahead and label my columns so I can reference them. 1, 2, 3, 4, 5, 6, and then 7. Okay, so column number 5 is not Q, and P. So that would be column 4, and column P would be 1. Okay, and the connective is AND. So how does N work? N is the statement that said both truth value has to be true in order for the statement to be true. So I will use, I think I'm going to use red for this column number 5. So I'm looking at 4 and 1. Okay, so reference 4 and then 1. False and true will result in a false statement because it's and. And means both have to be true in order for the statement to be true. False and true would be false. True and true is true. True and true is true. And then false and false is false. False and false is false. True and false is false. True and false is false. And that is how that 5th column is formed. And then the next one, I will go ahead and use green, not R. Not R means the opposite truth value of R. That is false, true, and didn't I say I'm going to use green? A little bit colorblind here. Hold on 1 second. Where is green? Green is right there. So I will have not R. False, true. R is true, so not R is false. R is false, and not R is true. Okay, it's the opposite of the 3rd column. So that would be false, true, false, true. All right. Now we are looking at, and then the final result is, and I am going to use purple for that. The final result is the connective if then, and we are looking at column number 6 and to column number 5. Okay, so the arrow goes this way. Okay, so how does if then work? The hypothesis has to be true in order for the statement to be considered. Okay, so if the only time that the hypothesis that the if then statement is false is if the hypothesis is true, but then the conclusion is false. Okay, that is the only time that that statement would be false. If the hypothesis is false, it doesn't matter what the conclusion is. The if-then statement is still true. So as soon as you see false to start your arrow, it doesn't matter what the other side is, you will go ahead and mark true because the conditional statement said if this thing happened, then something else happened. So if this thing happened and the second part didn't happen, then your if-then conditional statement is false. Otherwise, it will be true. Okay, so here, if this is true, when you see a true statement, to start with. You will look across. If it is also true, then your statement is true. But as soon as you see false to start with, meaning your hypothesis did not happen, it doesn't matter what the other side is, your statement will still be true. Okay, and then here you see that the hypothesis happened, so you're going to check, did the conclusion happen? The answer is no, therefore the conditional statement is false. Hypothesis did not happen, so it really doesn't matter what the conclusion is. Your conditional statement is true. Hypothesis happened, so you look across to see if the conclusion happened. No, it did not. So your conditional statement is false. And that is how you build a truth table for a compound statement. Pay attention to the order of connectives. That's what these little dots are saying. First order, second, and then I would go here next, and then I would go here last, right? And the order of connectives is first, parentheses, go inside parentheses first. That's why we started in there. Second, negation. Third, and, or. 4 would be if then, and then lastly, if and only if. That is the order of connectives. So make sure you follow that order when you are listing your columns, right? And if you have 3 simple statements, remember you have 8 choices. The first one would be when P is true, the first set, and the second set, the second 4 would be when P is false. And then what are we listing after that? Just our normal 4, which you have plenty of practice for. Those true, 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 false, false, true, and then false, false, right? Okay, that is it. Hope this helps.